Hello and welcome to this video lesson. The purpose of this video is graphing inequalities. Let's do a quick review on inequalities and how we can graph them in a 1D situation. So if you have a 1D, that means we only have one axis. In this case, we're saying x is larger than a. And if x is larger than a, if we were to plot it, we would have an axis with a indicated. And if it's just larger and it doesn't include the a value, we would put a circle. And since it's larger, that means the values are larger than a value, so they're actually to the right, and we put an arrow indicating that all the values go to the right. If it is larger or equal, we would put a circle, but we would fill that circle in, indicating that it's also equal and larger. We would put an arrow going to the right. So again, when it's equal or larger, we would fill it in, and when it's just larger, we would keep it empty. Now that we're dealing with a two-dimensional graphs, for graphing something that's just smaller or equal, we use dash line to draw our line. So instead of a empty circle, we use dash lines. And for graphing things that are equal, or equal and greater, or equal and larger, we would actually use solid lines. So for example, for the same example over here, this one was done in a 1D. Let's try to show how we would do it using a 2-dimension. So for 2-dimension, when it's just larger, we would find and indicate our value of a over here, which we have in this case. And I will just use blue. We will use dash lines. So if x was equal to a, that means that it would just be a dash line like this. So this line is indicating that x is a, but in this case, it does not include any of the values of a. So we would have to use dash line to kind of indicate that. And since it's larger, we would have to shade, last time what we did in a 1D situation, we highlight it using arrows, that is all the values to the right. So we do that either with two methods. We can either just put arrows like this, indicating that the x values are always larger than that a value, or we can simply just shade in that region like this. So one of the two, you don't have to do both, but one of the two actually works. For the purple one where it says that x is larger or equal to, what we did is we actually used a filled in circle. So now instead of a filled in circle, we will use, first of all, we have to indicate where a is. We will use a solid line because all the values are included, and solid shows that they're also included. That equal sign has to do with the solid line. And this one over here where it doesn't have the equal has to do with a dash line. And it's larger or equal to, so we would have to shade the region to the right, and we could also do that using, we could also shade it in instead. So again, the concepts are the same as doing it in 1D, except now we have a 2-dimension, so instead of just using one dot, we have to use a line to indicate things. So for graphing things that are just smaller or bigger, we use dash line. For graphing things that are equal or smaller, or equal than larger, then we use solid lines to draw our lines. In terms of which regions do we shade, for inequalities, we shade regions above the line. So if our line was like this, for example, we would shade above it, so everything above that line. If y is larger, or y is larger or equal to, which makes sense because y-axis goes this way, and if a value is larger than y, that means the upper region is shaded, and if it is smaller, that means the lower region is shaded. So that's kind of what's indicated here. And we shade regions to the right of the line if x is larger, and that's kind of the situation over here. So x values that are larger are to the right, and x values that are smaller are to the left. So we will shade the right region if x is larger or equal to, and we will shade the regions left of the line if x is smaller or x is smaller or equal to. So for this quick example over here, we have y is equal to 3 is the first one that we have to graph. So we know that that's a horizontal line. So I'll just do it with, let's do it with purple. Y equals to 3 will be a straight horizontal line this way. It's not an inequality, so I don't really have to shade above or below the region at all. For the next one, y is larger than 3, but it's not equal to. And since it's not equal to, instead of using a solid line, I am going to use a dashed line indicating y never actually equals to 3, but equals all the values above it. So y could be 4, y could be 6, but y can't be negative 2 because it's always larger than 3. So I will use arrows going upwards indicating that that region needs to be shaded. Or alternatively, I could just shade it in. The next one says y is larger or equal to 3. This time it's also equal to 3, so to indicate that it could also equal to 3, I will use a solid line. That means that y value here could be anything of 3 or larger, so it could be 4, 5, 6, 7, 8, 9. It can't be 1, so that region cannot be shaded. So if we shade this region, it says that y values here are always above 3. So I will use a solid line, and I will use arrows that are in the direction showing up. Or I will just shade this region. So let's do a few examples over here. You can actually pause the video and try these examples on your own, and then resume it just to check the answer. For the first one over here, it says x is smaller or equal to 3. So if x was equal to 3, that means it would be a vertical line. So I will draw a vertical line, and to draw it, I have to kind of look to make sure whether I have to use a solid line or a dashed line. This one is equal to or smaller, so I would actually need to use a solid line. So right at x equals 3, I will draw a solid line. And this is saying x value is always smaller or equal to 3. So that means x value can never be 4, 5, 6, 7, but it could always be everything smaller than 3. So that's this region over here. So I can simply just use arrows. Just use 3 or 4 arrows. You don't need to use that many. For the next one, it says y is larger or equal to x minus 3. So this one we haven't done yet, but let's try it out. What we have to do with this one is first we have to kind of draw y is equal to x minus 3 and then figure out which region we're shading. And to draw it, we have to figure out if we're drawing it using a solid line or a dashed line. And solid line in this case because it's got the equal sign. But to draw this, it's already in the form y is kind of equal to mx plus b. In this case, we're going to identify our m and b value. So our m value is the coefficient of x. In this case, my coefficient of x is just 1. And I can write that as a fraction and indicate this one as the rise and this one as the run. And my y-intercept is, or my b value here is negative 3, indicating that I have a point in the graph, which is 0, negative 3. So I can go on my graph and go to 0, negative 3, start here, and my rise is 1 and my run is 1. So from this point, I'm going to rise by 1, run by 1, rise, run. So I will indicate a few points on my graph, and once I have those points, I will draw a line through it. Again, I have to draw a solid line because it is equal to, so that will look something like this. And now the next part is, because this is an equality, it's saying y is larger. So if it's larger, I have to shade above the line, and here is my line. Above it will be everything in this region, and below it will be everything in this region. So since it's larger, that means we're talking about these y values over here. So I can just shade, or just put an arrow indicating that direction. Now, just to check this answer, we could also look at the x value. If we were just to look at x over here, it says that x is smaller than some other things. And if x is smaller than other things, that means that we would have to shade to the left-hand side of our line. So if this is our line, its left-hand side is this direction, which is consistent with what we have when we did it using the y value. So the answer actually makes sense. And again, you could shade as well, but you don't have to. The arrows are enough to indicate the shaded area, especially when you just have one graph. Also want to label your graph over here. So this one, the graph that we drew was y is equal to x minus 3. And the graph on the left-hand side that we drew was x is equal to 3. And after we drew this line, we actually shaded the proper region. And after we drew this line, we drew the proper region. So it's nice to label your line as well. All right, let's do two other examples. I want you folks to actually try this one out on your own. Try A and B on your own, and then we're going to take it up. Alright, so for the very first one over here, we have y is smaller than x. So if y was equal to x, then we're going to indicate what our m value is and what our b value is. This is same as saying y is kind of smaller than 1x plus 0. So our b value is 0. And our m value is 1 because we have 1 times x, which is 1x. And I will write this as a fraction of 1 over 1, indicating my rise and my run. And when b value is 0, that means it goes through a point 0, 0 over here. Alright, this is great because I now have my 0, 0 point. I know that my rise is 1 and my run is 1. That means I go up by 1, right by 1, and I will put a few points over here just to kind of indicate my line. And I can put a few points backwards because you could also have negative 1 over negative 1, which also gives you 1 as your slope. So now to draw this out, I have y is less than. It's not equal to, so I can no longer use solid lines. I have to use dashed lines. So I'll just change these into dashes. And it looks fantastic. So I have a line like this. When you're drawing these lines, just make sure that you're using most of the graph. I sometimes get students who just use very small amount of the graph, and it doesn't really help much. It's really difficult to see. So in this case, y is less than x will be indicated. Since it's less than, then we have to shade below the region. So if this is our line, that means we have to shade this region over here because it's less than. The other way of looking at it, x is larger than y, so that means we have to shade the right region of the graph, which is pretty consistent and it makes sense. So I will shade this region, or just use a few arrows indicating that it's this region that needs to be shaded. Now the next one is saying that 4x minus y minus 2 is less than 6. This is not in a form that I can easily graph. I will have to either change this into a general form and kind of find the x and y intercept, graph the line, and find out which way to shade. or I can just change this into y is equal to mx plus b format, which is exactly what I'm going to do. So I'll write it again. 4x minus y minus 2 is less than 6. To get it into y is equal to mx plus b format, I will need to rearrange for y. So I'm trying to isolate for y over here. I have negative y over here. I have 4x minus y. That means I have to subtract 4x from both sides to get rid of this term. And then I have to add 2 to both sides to get rid of this term, and then I will have negative y on its own, and then I will have to multiply or divide by negative 1. So let's do that now. So first step over here, I am going to subtract 4x from both sides, and I will get negative 5 minus 2 on the left hand side, and on the right hand side I will get 6 minus 4x, or simply negative 4x plus 6. Now, if you remember from inequalities, when you subtract a value or add a value, it doesn't really matter what they are. It's a safe operation and your sign doesn't actually change, so our sign stays in the same direction over here. The next step is to remove the negative 2 from this side, so we do that by adding 2 to both sides. So plus 2 to both sides, and I get negative 5. And again, adding does not change the sign. Negative 4x plus 6 plus 2, which is just plus 8. So I'll just indicate that as plus 8. Okay, I almost have it in the proper format. However, this is negative y, and we do want it y is equal or less than or larger than something else. So we need to isolate for y and not negative y. So I can multiply both sides by negative 1, or I can divide both sides by negative 1. It's the same thing. However, if you remember, multiplying or dividing my negative value means that it's an unsafe operation for inequalities, and that means I would have to switch my sign over here. So y is now larger than negative 1 times negative 4x gives me positive 4x, and negative 1 times positive 8 gives me negative 8. So that's kind of my final rearranged form over here, and something that I can easily plot. So looking at this, we can see that it's in the format of y is equal to mx plus b. My m value over here is the coefficient of x, which is just equal to 4. And I can write that as 4 over 1, where 4 is the rise and 1 is the run. And my b value is equal to negative 8, meaning that I will have a point 0, negative 8 as my y-intercept. So I can start at that point over there, 0, negative 8, and I will have to rise by 4 and run by 1. And I will do a few points just to get a good idea about how to do my line. And again, I don't have a ruler here. When you folks are doing it, please use a ruler to connect your lines, and here, or to connect the points to make your line. In this case, it's small, it's just larger. So when it's just larger, I can't use solid lines, I have to use dashed lines. So I will do that right now. And put my arrows. And once I have my arrows, I will need to shade the proper region. In this case, y is larger. If it's larger, that means I have to shade above my line. And if this is my line, this region is below it and this region is above it. So to shade the proper region, I will need to indicate that it is this direction over here. Another way of looking at it again is I have 4x over here, or you can also isolate for x by dividing everything by 4. And in this case, x is smaller than other things. And if x is smaller, that means you have to shade to the left region. So that would be this region. So it's consistent using both method. And that kind of kind of is a check mark for figuring out if you did this correctly or not. Finally, I would like to label my lines over here. This line over here is y is equal to 4x minus 8, and that's kind of this line over here. It's not really the shaded region, but the line is y is equal to 4x minus 8, and this line over here is simply y is equal to x. And the inequality is kind of shown by this region, so you don't really need to write that one down, but it's nice to have these labels. You sometimes get situations where you have to find intersection of two inequalities, and to graph the intersection of two inequalities, you simply find the region which is shaded by all of the inequalities. So let's go through this example and it will all make sense. Our first graph is y is larger than x, so we want to draw the line y is equal to x first and then draw the proper region based on that. So our m value over here is 1, which is same as 1 over 1, where the numerator is the rise and our denominator is the run. Our b value is 0 in this case. X is being added to absolutely nothing, and that means that our y-intercept is at 0, 0. So we start at 0, 0, we go up by 1, which is our rise, and we go right by 1, which is our run. And I will put a few dots over here, just indicating that. And then we will have to figure out if you're drawing this as a line, as a solid line or a dashed line. Since it's just larger and it's not equal to, we are going to use dashed lines, so it will look like this. The line that we drew over here is y is equal to x, so we will label that. And the region that we need to shade, it says y is larger. If it's larger, we're looking at y values which are large and not small. So we would actually have to shade the region above. And when you're finding intersections, it's actually better not to shade and just put the arrows first. And then we're going to start shading once we have the common region. For the next graph, it's y is smaller than 3. So y is equal to 3 actually looks like a horizontal line that passes through the 0, 3 point, or has the y-intercept of 3. So we can draw that, and since it's only smaller and it's not smaller and equal to, then we are going to use dashed lines like this. And again, since it's smaller, we have to shade below the region, so that would be this region over here. Now, for the intersection, once we have the two lines, actually, I should label this one as y is equal to 3. That's the line we drew. For the intersection, after they connect at one point, it will divide the whole regions by 4. We have one region here, one region over here, one region over here, and one over here. We can see that from the first one, this region is shaded, and from this one, this region is shaded. So this region is only shaded by the purple. This region over here is not shaded by the purple or the blue. This region over here is shaded by the blue, but not the purple. But this region over here is shaded both by the purple and the blue. So to find the proper region, I will need to shade this one, indicating the proper solution. So if you are looking for the intersection, then use arrows to indicate which direction things are, and then shade the proper region. Alright, let's do a few examples over here. The first one says y is larger than 3 and y is larger or equal to x minus 2. So I will use blue for the first one and purple for the second one. When y is larger than 3, that means it's a horizontal line. We don't use solid lines because it is not equal to, so this is y equals to 3, and since it's larger, then we have to shade the region above. For the second one here, y is larger or equal to x minus 2. In this one, we don't have a horizontal or vertical line, so I would actually have to figure out what my m value over here is. M is the coefficient of x, in this case 1, which is same as 1 over 1, which is my rise, and which gives me my rise and my run. And my b value is negative 2, meaning that I can actually know that my y-intercept is at point 0, negative 2. So I have enough information to actually draw it out. I will start at my y-intercept, which is 0, negative 2, and rise by 1 and run by 1. And I will put a few dots over here and a few down here, and I will connect them. This time it is larger or equal to, so I will actually draw a solid line because the equal sign is there, and I will indicate that this is y is equal to x minus 2, and since it's larger, I would have to shade the region above. For the shaded region, we are going to look at 4 regions. This one, this one, this one, and this one. This region over here is not shaded by purple, which is this way, nor the blue, which is here. So it's not this region. This one over here is shaded by the blue, but not the purple. This region over here is shaded by the purple, but not the blue. And finally, this region over here is shaded both by the blue and by the purple. So my actual final answer here and my final solution would be this region over here. Alright, the next one over here is a little bit more involved because I have 3x plus 2y is less than or equal to 3, and that's not given to me in y is equal to mx plus b format, so I have to kind of change that first. So I'll write it out again down here. I have 3x plus 2y is less than or equal to 3. So I want to isolate for y. So the first thing I will do is remove the 3x by subtracting both sides by 3x. So subtract 3x from both sides. This is not an unsafe step because subtracting or adding values does not change the equality sign. So I get 2y on the left hand side, and on the right hand side I get negative 3x and plus 3, or 3 minus 3x. It doesn't really matter which way you do it. And now I have 2y over here. I need to isolate for just y. I know that y is being multiplied by 2, so to remove the 2, I have to divide both sides by 2. Dividing or multiplying by a positive value does not change the sign, so I can divide this side by 2, this one by 2. These ones cancel. The sign remains the same, so y is less than or equal to negative, and I will break this down to negative 3 over 2x plus 3 over 2. And once again, algebraically, I have negative 3 over 2x, which is down here, and I have 3 over 2, which is down here. Now I have it in a form that I can actually plot. Unfortunately, I'm dealing with fractions, and my starting point is also a fraction. Let's actually write it down. My m value is negative 3 over 2. Just write the negative on top. So this is my rise and this is my run. And my b value is 3 over 2, meaning that my y-intercept is at 0 and 3 over 2. So 3 over 2 is same as 1.5, so I will start at that point, and I will rise by -3, meaning I will actually fall by 3, and I will run by +2. So that would give me a point over here. So from here, I'm rising by -3, so that's 1, 2, and 3, and I'm running by +2, meaning I'm going to the right by 1, 2. So that's my next point, and I will draw at least one more point. 1 is here, and 1 is here. And that's enough points to kind of give me a good idea about how to draw it. And again, you're using a ruler, so it's a lot easier to do. So let's draw this one out. And it's actually equal to as well, so it's actually a solid line. So I'm trying to use as much of the graph as possible. And we know that it's actually less than, so we know that it's actually the region below the graph, which is this region over here. Now, for the second one over here, I have y is larger or equal to x minus 2. This one is nice because it's already given to me in terms of y is equal to mx plus b, so I can just find my slope as 1 because that's the coefficient of x. This is same as 1 over 1, meaning my rise is 1 and my run is 1, and my b value is -2. It's actually identical to the last question. So that means it goes through the point 0, -2. So I will start at 0, -2, and I will rise by 1 and run by 1. So I'll put a few dots and I will join them using a solid line because my inequality says it's larger or equal, and the equal means that it is a solid line. I will say that this is y is equal to x minus 2. I will also say that this one over here is y is equal to -3 over 2x plus 3 over 2. Once I have this, I will have to, actually, I forgot to shade the purple one. The purple one says larger, y is larger, meaning it's above the line, which is in this direction. And now I have 4 nicely divided regions, this one, this one, this one, and this one. And the region that's shaded by both is actually this one, because you can see the purple shades this way and the blue shades this way. And just to shade our final answer would be this region right here. Finally, we will look at an example to tie everything up and to kind of give you an idea of where inequalities can be used. So in this example, it says Mr. Shateri has 2 cameras. His Canon camera takes photos that are on average 20 megabytes. So raw photos coming out of an approximately 16 megapixel camera are between 20 to 25. Let's say 20 megabytes for this case, and Nikon cameras that are on average 30 megabytes, so it's a little bit larger megapixel in this case, giving you larger photos. He has a USB which is 8 gigabytes, which means that it's 8,192 megabytes of storage. He will take at least 50 photos with the Nikon camera and at least 80 photos, but less than 200 using his Canon camera. Graph the inequalities to show the possible number of photos he can take with each camera within this space limit. So we want to see if he has this much space and he has the 2 cameras, what are the possibilities of how many photos is he going to take with his Nikon, and how many will he take with his Canon. There's a little hint over here. It says let X represent the number of photos taken by the Nikon camera and Y represents the number of photos taken by the Canon camera. So let's start with some inequalities. It says that, let's start with the later ones. They're a little bit easier to actually put down. He will take at least 50 photos with his Nikon. So we're letting X be the number of photos that are taken with the Nikon camera. So if he's taking at least, that means he could be taking 50 or more. So we know that X has to be larger or equal to 50. And I will label this at least 50 with Nikon. The next one here says he will take at least 80, so that means 80 or more photos with the Canon, but less than 200. So not 200, but less than 200. So to show this part, and I will highlight this actually using green. So this one over here means that, first of all, photos by the Canon are represented by Y. So Y has to be larger or equal to, because it says at least 80, but it has to be less than 200. It can't be 200. And we can also break this down into two inequalities, one saying that Y is larger than 80, and one saying that larger or equal to 80, and one saying that Y is smaller than 200. But it's actually nicer that it is in one set of inequalities like this. The final set of information, I will highlight this one with blue, is that the storage itself, well, a few things. Takes photos that are an average 200 megabytes are each photo coming out of the Canon, and Nikon camera 30 megabytes, and the USB has this many megabytes. So to write that as an inequality, we know that X represents the number of photos by the Nikon camera. So if he takes one photo, it's 30 times X. So we're trying to figure out the space here. So if it takes one photo with his Nikon, it's 30 megabytes. If it takes two, it's 60 megabytes, and so on. So 30x will be the space by Nikon plus the amount of photo that he takes from the Canon camera. Each one is 20 megabytes multiplied by Y, because Y is the number of photos being taken by the Canon. So this is space by Canon. And this space cannot exceed, so it has to be less than, I'm going to say less than in this case, not even equal to, because usually you don't get 8,192 megabyte of storage, is always less. So I will say 8,192. Alright, so now we have to plot these or graph these things. I am going to start with the blue equation. 30x plus 20y is less than 8,192. And I'm starting with this for one good reason. I don't actually know what the scaling here should be like. So what I will do is actually find the x and y intercept. And once I have those 2 points, I can actually figure out what the scaling for my x and y would be. To find the x-intercept, I will set x equals to 0. Actually, to find the y-intercept, I will set x equals to 0. So 30 times 0 plus 20y. And I will set it to equal in this case, just because I'm finding the intercept. and this will be 0, so 20y will equal to 8,192. So y will equal to, and once I do this, I will get 409.6. So that's my y-intercept. So y-intercept is at 0, 409.6. And I want to find my x-axis at x-intercept as well by setting y equal to 0. So then 30x plus 20 times 0 is equal to 8,192. And that means that 30x is equal to 8,192. Divide both sides by 30, and I will get 273.06. I'll just round this to 0.1 for now. So I know that my x-axis over here needs to go up by, the maximum value should be 270, and on the y-axis I want to go up so that I can at least show 409. To do this, I will go up, so I need to show at least 409 on the y-axis. So if I go up by hundreds, I will get 100, 200, 300, 400, and 500 down here. And I will label my y-axis as number of photos with Canon. And my x-axis is number of photos by Nikon. I need to go up to a maximum value of 300. I will just use the same scaling here, 200, 300, 400, and that should be enough there. I will label this as X, label this as Y, and then I will put approximately my points over here. So I know that my x-axis is approximately 273, so that's somewhere here, and I can label that, but I'll just label the line later. And 409.6, which is approximately 410 down here. And I know in terms of my equation, it's less than, and if it's less than, I have to use dashed lines. So here's a nice dashed line over here. And I know that when I look at the 20y, it says that it's less than this value. And when I look at also 30x, it's also less. So if 20y is less, if the y is less, that means that I have to shade below the line. And if 30x is less, that means that I have to shade to the left-hand side of the line, which both of them are consistent. Both of them are in this region over here. So I will now put some arrows indicating this direction. Now, next thing I will do is this one over here. This one says x is larger or equal to 50. That one is actually really easy to draw. I just have to figure out where my x is equal to 50 is. It's larger or equal to, so I will have to actually draw a straight line. So x equals to 50 is actually here. So I will draw a straight line going up, which is a vertical line, and is larger, so I will have to do this region over here. So that's right region. And I will write that this is x is equal to 50, and I will write that this one over here, the first one that we drew, is 30x plus 20y is equal to 8,192. Finally, for my very last one over here, it says that y is between 80 and 200. For the 80 is also equal to, so if y was equal to 80, that means that I would have to draw it as a horizontal line. So actually I'll do it with green. So 80 is approximately here. Horizontal line would be something like this. So this is y is equal to 80. And I have y is less than 200, but it's just less than and it's not equal to. So I have to use dash line on this side. So if y is less than 200, then I will need to use dash lines. And this is y is equal to 200. And now y is larger than 80, so I have to shade above it, and y is less than 200, so I have to shade below it. So it's actually this region over here. So I will actually do two sets, one set showing that it's this region down here, and one showing that it's this region up here. Now, the region that's shaded by all of them is actually this region right here, which I am highlighting, so you can actually see this green region right here is the area that's shared between all of these inequalities. So what does this mean? So if we have a set of restrictions like the ones that are given to us, we no longer have just one solution. We can't just say you have to take 51 photos by the Nikon camera. You have to be able to say that, oh, we can take, for example, 51 by the Nikon and maybe 91 by the Canon, or we have to use that restriction. So here, this region over here shows us all the possible solutions. So for example, since we know that the X is photos taken by the Nikon, if we were to take 400 photos by Nikon and 0 photos by the Canon, that means we're looking at a point over here, and that is not part of the solution. So we can't actually take 400 photos by the Nikon. And that actually makes sense because if we were to multiply 400 by 30, which is how big each file is coming from the Nikon, we would actually get 12,000, and 12,000 is much bigger than the space that we have, so we actually can't make that happen. If we were to take 100 photos by the Nikon and let's say 350, it's not part of our solution, so based on our restrictions, that can't be an answer. If we were to take 100 photos by the Nikon and 150 by the Canon, that's okay. We could do that. If we were to take 100 by the Nikon, 200 by the Canon, we actually can't because that's a dash mark right there. So we have to be taking less than 200 by the Canon. If we were to take 50 by the Nikon and let's say 150 by the Canon, we can actually do that. So any photo, so we can take any coordinate over here, and the X value would represent the number of photos taken by the Nikon, and the Y values photos taken by the Canon, and any of those values would actually work based on the restrictions given in this question. I hope that gives you some good idea about how inequalities can actually be used in real life. This example, again, is a little bit more involved. It kind of uses a lot of our skills. It uses inequalities, it uses graphing inequalities, it uses finding x and y intercepts properly. And I forgot to actually mention over here that our x-intercept is at 273.1 and 0. And it also has some more challenging inequalities that we have to graph. So all of them are here, but just make sure that you kind of understand why we're using these ideas and what kind of questions we can model by inequalities.